PT is a method that amplifies the strength of concrete structures by creating a compressive stress. Basically, it's used to make concrete resist heavy loads and forces on structures. Engineers have known the principle of pre-stressing for centuries, but it was only in the 1920s that they started to apply this technique successfully to concrete structures. At that time, reinforced concrete was already in use. In this case, the concrete is strengthened using steel bars, deforming when a load is applied to the structure. But there is an issue. Reinforced concrete starts to crack as soon as the steel bar deforms by load. These cracks can then let in water or other damaging substances. There is a solution: to compress the concrete in order to counteract the effects of tension stresses created by the load. That is how pre-stressed concrete was born. Post-tensioned concrete is a method of pre-stressing. The concrete is stressed before the loads are applied to the structure. But for PT, the tension is applied after the concrete is poured and cured. It is therefore easier to install. The process is quite simple to understand. Take part of the reinforcing bars out of the concrete and replace them with steel cables called tendons, usually made of strands. These strands are placed inside ducts, which are positioned into the concrete structure's formwork before the concrete is poured. After the concrete is set, the strands are anchored against the outer edges of the segment and tensioned. Once the strands are tensioned to the correct force, a bit like tuning the strings of a guitar, but more complex and critical, you can carry colossal loads. Under the force of these tensioned tendons, our concrete beam arches upwards slightly. When supporting very heavy loads, the arch straightens out, but the structure does not bend downwards. No crack opens, and the structure's life expectancy increases. Its installation process involves various steps. Step 1. A bearing plate is fixed to each end of the beam's formwork, with a duct connecting the two plates. These plates allow the transfer of the very high and localized stressing force to the concrete. Some reinforcements are needed, especially near the bearing plate, and are installed too, at the same time. Step 2. The concrete is poured into the formwork. Step 3. The steel PT strands are threaded through the duct. Step 4. Small conical steel pieces called wedges are installed to fix the strands to the anchor head. The strands are now connected on each side. In Step 5, the strands are stressed using a jack. Constant recording of stressing data takes place during this operation. The data must meet the values that the engineers calculated when designing the structure. After the protruding ends of the strands are cut, a sixth and final step follows, called grouting. The grout is injected into the ducts all around the cables to protect them from corrosion and provide bonding to the surrounding concrete. Grout preparation is rather like following a cooking recipe. The mixing and amounts of ingredients must meet very strict requirements. Before and while being applied to the cables on site, this mixture is subjected to numerous tests because the stakes are high. Too liquid, it would not protect the cables from corrosion and would jeopardize the solidity of the structure. Too viscous, and it would be impossible to inject into the ducts. This might sound easy. However, grouting needs to be carried out very precisely to meet the design objectives. PT has many different applications and is used in civil works, building, and the construction of industrial facilities. Other techniques, including stay cables and heavy lifting, also have their origins in the strand post-tensioning system that VSL has been developing for more than 50 years. But this is for another chapter.